Hello, internet friends. How's it going? I apologize for the extra clutter and flashing lights and noise today. I'm putting together a new network attached storage there. I've got a like 15-year-old Celeron box downstairs that's been doing it. It's out of space, so stuff's got to copy over. Gonna take a little bit. Anyway, if I can keep from bumping stuff and screwing up all of my stuff, because I just created this software RAID 2 and it's rebuilding, and if I reboot before that is done, I will have a headache. So I don't want to accidentally hit the power button on that Raspberry Pi over there while I'm messing around here. But anyway, we're back with the the Zenith Z-19 again today. And in the last video, you recall, if you watched it, you'll recall that we got the thing working and we logged into the ProLinea's Slackware installation via the serial port. And that was spiffy, but in the process of trying to get it working, we found this AC voltage transient on the chassis. So I was just looking inside of here and looking at the schematics and trying to figure out what might be going on. So let me put you on the stand and we'll see if we can. I don't know what's going on yet, so hopefully this won't be too boring, and hopefully you won't be pounding your head against the table too hard from my dumbness. So let's see what we can find out. So the way that, the way that I found this originally was, watch it not even be doing it now. The way that I found this originally was when I was making a new serial port cable for this thing, because I was confused about things, and I need to take this DCE sticker off of here too, because it is not any DCE any longer, because I'm an idiot. Get off of their sticker. Okay, now good as new. Right. So I was trying to figure out which pin was which on the serial port, and which was the RX and which was the TX pin. And I noticed this weird slope on my digital oscilloscope that looked like part of a sine wave. So took the meter, and if we measure from the chassis to the logic ground, which is pin number 8 inside of the serial port here, okay, we've got like a 3-volt transient right now, which isn't terribly unusual. There may be one of these big capacitors that's like still discharging a little bit, or something. It's nothing to worry about. But watch what happens when I turn the power on. If I can keep that on the chassis, I've got the shield on the serial port disconnected from the chassis ground right. Well, actually, it isn't right now. But the frame ground pin down here inside of the shroud is disconnected anyway. So watch what happens when I turn the power supply on. 60 volts AC between the logic ground and the chassis ground, and it's not unusual for there to be some voltage differential there, but not 60 volts AC. That's not right. So since I'm dumb and I didn't think of it on my own, I asked around on the Vintage Computer Federation forums, and a gentleman by the name of Chuck, who's very active there, said that it's probably one of the X2 AC line filter capacitors leaking. And I slapped myself in the forehead and said, oh duh, because I should have thought of that myself, but I was too dumb at the time. But then I looked in the schematic, I don't see any AC line filter capacitors. So let's look at the schematic, and I'll tell you a couple of theories I've got, which are like way out there, you know. I'm probably full of shit altogether. And then we'll poke around here and see if we can figure out what's going on with the power supply board. But you know what? Before we even do that, well, no, let's look at the schematic first. I want to be sure I'm doing stuff right, or at least less wrong. Okay, I'll be right back. All right, so here is the power supply section. Can you see that? It's a very fuzzy schematic, but we can barely make it out. So it's a linear power supply. There's supposed to be a switch here somewhere that switches between 120 and 240, but I don't see that anywhere. There's a power switch, a slow blow fuse, and then there's this multi-winding transformer that's got several outputs for different stuff. There's this output here that goes to the video board. I'm not sure what voltage that's supposed to be. And it's got a couple of other outputs down here. One that goes through and then there are a couple of linear regulators here to get a pair of 5-volt supplies, I think, if I'm reading this fuzz right. And then there are some more linear regulators down here to give us positive and negative 12-volt sources and a negative 5.2 volt source. I'm not sure what that's for. Maybe it's got some weird old RAM that requires a weird voltage. I'm not sure. Anyway, so this all of these voltage regulators, though, these linear regulators, are actually on the terminal logic board. So the power supply section is just this, and I think I can just unplug one connector and disconnect all of this stuff from everything else. And we've got all of these grounds here. There are 3 different black wires coming from 3 different secondary windings on this transformer that are all tied to ground, and also the chassis of the transformer is tied to ground, which isn't shown on here, but there's a nut under here that the chassis ground wire goes under. So and there are some filter capacitors on here, but I don't see any AC line filter capacitors on it, though. All of these are on the DC side of the rectifier bridges here, but well, okay, that gives me an idea, maybe. But let's unplug the power supply from the machine and check voltage potentials between these grounds and see what's going on there. Maybe. Yeah. Okay, so let's measure the DC voltage here on these different wires. It's not going to be very smooth, but we'll check it anyway just to see what we've got here. Okay, this blue wire and this black wire all the way on the left here go to the video board. So let's check it, them, whatever. Let's see what we've got here, hopefully without shorting something. Okay, so that's 63 volts, and okay, there's a 60 plus 65 written on the schematic here. Wasn't sure what that was supposed to mean. So that's 65 volts DC going to the video board. Now, the next, and that's all on one secondary winding on the transformer up there. The next 2 are supposed to be 8.5 volts, the red one and the black one. Let me zoom you out here a little bit. Oop. Then you ought to be able to see the meter a little better, because I'm not watching the camera while I'm poking around live 120 volt stuff, because that's not good. Okay, 8.5 volts. That's really good. Now, the last 3 wires are a center negative, or a center ground, and then the orange one is supposed to be. The orange one is supposed to be. I can't read the writing on the schematic. It's too fuzzy. One of them is supposed to be positive 16 volts, and the other one is supposed to be negative 16 volts. Because of course we need a little bit higher voltage to go to the linear regulator to knock it down again. Okay, positive 15 volts there. And this will still say positive 15 volts because I've got my leads swapped. But yeah, okay, so the voltages there, I think they all make sense. But if we turn off the power and remove this connector, okay, then I ought to be able to power the thing back up and see if we've still got voltage between the chassis and any of these black wires, the pins on the power supply, I mean. So let me get some alligator clip leads here. I'll be right back. Alright, so for this test we've got the meter back on AC volts because we're looking for that funky transient, and I've got an alligator clip lead here that I'm going to stick on the chassis ground down here, and then we ought to be able to check these pins with the other lead. So the second one is the ground. The power is off right now. The second pin here is the ground that goes to the video board. 2 volts. That's nothing to worry about. This is the 5 volt side winding on the transformer. It's got 3 volts on it, nothing to worry about. And then this middle pin is for the 12 volt side of the transformer, and it's also got 3 volts on it. Nothing to worry about. A little bit of a transient there, but that's probably coming in from the AC line. I don't know. So now I'm going to power it up. No beep because of course the power is disconnected from the terminal logic board. So let's see if we can see that weird voltage transient on the CRT power supply ground pin. If I can get this thing out of the way. Stay back there, Bubbo. Alright. Oh, if I knew what I was doing, I'd be dangerous. Alright, so it's got 8 volts on it, so that filter capacitor must be like maybe leaking a little bit. On the DC side. See, the DC side isn't smooth. Okay, there we've got our 66 volts now. That is on the ground side of the 5 volt secondary winding, or 6 volt, 6.5 volt according to the schematic. Okay, so now let's check the ground on okay, there it's, we've also got it on the ground pin for the 16 volt windings. Okay, so this thing with the blue stuff on top of it, that is a great big 1500 microfarad filter capacitor on the line, the DC side that goes to the video board. And okay, so it's downstream of this connector here though. So it's got all these rectifier diodes here, right? And there's no rectifier bridge, it's just got individual diodes arranged in a bridge the way that they're wired. See, here's see if I can get this under here. Yeah. See, they're wired into a rectifier bridge here. So the AC, the low voltage AC comes in one side and then gets turned into direct current. A very unsmooth direct current goes out here. Alright, so, and that's our big 1500 microfarad capacitor right there. Down here on the 5 volt side, there's a great big 10,000 microfarad capacitor. Let me get this out of the way. There's a great big 10,000 microfarad capacitor and a couple of smaller. This is on the 6.5 volt one. And then there are two 470 microfarad capacitors down here on the 16 volt low voltage side. And so I've got this thought that, like, so if there's something wrong with one of these, oh, you can't see them. Okay, so right here, these are the rectifier diodes right here, okay? One set for each section, right? And if something is wrong with one of those diodes, like it's not blocking current in one direction like it should be, that might account for this AC transient voltage on the chassis that we're seeing. And if that's the case, we'll probably only see half of a sine wave if one of these diodes is bad. Now, I may be completely full of shit. I'm just surmising here now. Okay, so let's hook a probe up to the chassis and one of these pins that we've got the transient on, and look at it on an oscilloscope, and then we'll be able to see whether it's just half of a sine wave or not. Yeah. It is off, right? Yeah. Okay. Go down in here and clip back onto that thing, and then, okay, this one here had the transient on it. Alright, let me get my scope hooked up and I'll be right back. Alright, I'm going to use All Reliable. He's probably a little bit better at syncing high voltages if we do something stupid here. Come on, bud. Come on. Come on. Come on, you can do it. Okay, so that, according to the vertical gain switch, this scope is not calibrated at all, so I'm going to guess what we're seeing here is that 3 volt transient that we were looking at before. So if we turn the vertical attenuator down a little bit there, stick that in the middle as best we can. Can't really see the scale on this thing. The bulbs are burned out. Well, one of them still works, but it's like up here in the corner. Okay, now let's power it up and hope that I don't fry my scope. Okay, that's a full sine wave. Let's see if I can get the vernier adjusted right here. That's a full sine wave. So I mean, I really don't know what I'm doing, but that makes me think that that can't be a rectifier diode then. Oh, don't start shifting. I need to replace capacitors in this thing too. Oh, come on, Old Faithful. Hold still. Yeah, okay, well, that, I guess that tells us something, maybe. Probably tells you more than it tells me, because I don't know what I'm doing. Okay, let's try to test those diodes with an ohm meter here. Let me hook you back on the stand. Okay, so I cut some stuff because I'm a dummy, and I had my meter on the wrong setting when I was testing these diodes, and I thought that one of them was bad, but wasn't, and desoldered it and replaced it, even though I didn't need to. Oh, here I go again. Wrong setting again. Okay. Diodes are all good, as far as I know. Yep, diodes are fine. So my only other idea is that it might be one of these capacitors leaking. I don't know if we can test them. I don't have an ESR meter. These little ones we can probably test. Charge, discharge, charge, discharge, charge, and discharge. Now this big one, I don't know if my meter will even do anything to it. According to the schematic, this green wire with the yellow stripe is supposed to be the center tap for the 16 volt and negative 16 volt sides, and it ties straight to ground. So I'm going to try to measure AC voltage between that wire and the chassis and see what I get. And there is our 60 some volts AC. Yeah, I don't know. I don't know what to think about that. Unless it's something underneath of here. The schematic doesn't say there are any AC line filter capacitors under there anywhere, but I guess I'm going to open it up and look. Because if it's not an AC line filter capacitor, then I guess it's just coming out of the transformer. If that's the case, I don't know what to do about it. I mean, the thing works, so I guess if we don't figure anything out looking under here, then I just won't do anything to it. No line filter capacitors under here. Maybe it's a design flaw, I don't know, but I can't see as how having a voltage potential of 65 volts between the logic ground and the chassis could be a good thing ever. So I don't know if you guys have any ideas about what might be causing this. Please let me know. I mean, this line right here that goes straight down here to chassis ground well, straight down here to logic ground, I should say, is the one we tested. And I mean, it's just that transformer. There's nothing else here. There's nothing else here that could be bleeding it. It must just be the way the transformer's wound. I mean, the voltages were alright. So, I don't know, man. If you've got any ideas of what's going on here, why, please let me know. I'm stumped. Surely there's not supposed to be that much of an AC transient between logic ground and the chassis. Surely there's not. Well, it'll have to remain a mystery for the moment. The machine still works even after all of my inept bumbling, so I guess that's the most important thing. I guess if all else fails, I could just remove this whole linear power supply section other than the switch down here and put in a modern switching power supply to run everything. And then that would probably solve the entire problem, but I kind of don't like to do that sort of thing. I don't know. Big transformers are cool, but 65 volts. I don't know, man. It's a little strange. Thanks for watching. Maybe next time we'll actually solve some of the mysteries. Have a great weekend.